want to welcome you to our expert breakout sessions for CloudCon integration and Web API. This is the breakout session for Jeff Reeser, Senior Product Strategist at Progress Software. Jeff, welcome back to CloudCon.
Thank you very much.
We're really happy to have Jeff with us this morning. He leads big data and cloud data product strategy for Progress. And in the past, he managed business process management offerings at both Progress and IBM. In fact, Jeff brings 30 years' experience in enterprise IT. And it's a great pivot point for all this new conversation around integration because his portfolio includes big data, BPM, cloud, business rules, and he even managed IBM's Webster application server from the start. So terrific credentials here that we have this morning in this new conversation in cloud integration. And in Jeff's session, he tackles top 7 data API headaches and how to handle them. Jeff will discuss the challenges in how accessing pertinent data and transform that information into actionable insights. He'll also explain how these challenges can be addressed with cloud services to keep things low cost and simplified. And because we believe in helping map out success for all of our attendees here at CloudCon, Jeff will provide some use cases and examples in real business. Just a quick reminder before I hand it to Jeff, if you haven't already done so, you can download his slides right now. Just click the link under the viewing area. In that same region, you'll see Jeff and his team have brought some other terrific downloadable resources, white papers and data sheets and so on. They're there for you right now. And we love to make this interactive where we can. So to connect with Jeff, simply type into the Submit a Question box. And now, Jeff, let me hand it over to you and talk to us about top 7 data API headaches and how to handle them.
Thank you, and it's a real pleasure to be here today to talk to you. And I'm going to be discussing some of the key challenges, like you said, in dealing with some data APIs and things that gives a lot of us headaches and sleepless nights. In the process, I'll show some real-world examples of how these data API headaches can be triaged and treated with simpler approaches involving, in a lot of ways, cloud-based services and more. So with that, let's talk about the data API headaches themselves. And it seems like no matter what sort of environment your applications are running in, there's always going to be a need to collect data in order to move forward in your business processes. And along that journey, there's going to be undoubtedly some frustrations and time added in gathering the right data for making the right decisions for the business. I'll go through 7 of these scenarios in this discussion, as you see here. And most of these are challenging because of where the data resides, as well as what the approach is to get to it. You could be dealing with multiple data APIs, or connecting to data from mobile devices, getting to enterprise data, dealing with big data, or heavy transactional operating environments. The first headache is due to having to deal with the explosion of new and different data sources, especially in the cloud. Having many different and varied connections makes API management far too complex, and it's not a very scalable environment. And each API could be unique to that data source, with some native APIs even being proprietary. Also, these native APIs often change frequently. The native Salesforce.com API, for example, gets updated every single quarter, whether you like it or not. That means if you are relying on it within your applications, you might need to update every app that uses it as well to accommodate those updates. And the third point here on the slide is on development cost. Since there could be many different data APIs to handle, and since many of those involve unique skill sets to understand them, and since, again, many of those could often change frequently, it becomes a nightmare to maintain. And the cost of multiple API management explodes along with this explosion of new up-and-coming data sources out there that you're going to need to access. So basically, how do I simplify this chaos created with the growing variety of data APIs that's out there? There are many vendors out there today who are addressing this problem by providing a cloud-based service for data connectivity. And this connectivity service is then responsible for understanding and managing all of the various and unique data APIs for a broad spectrum of data sources. As a data-driven application developer, whether I'm building a SaaS application in the cloud or an analytics tool or a mobile or a web application, I want to stick to what I know and understand the most. I'm familiar with SQL, for example, from my enterprise data experience, so my preference is to use SQL whenever I can to access data, whether it's in Salesforce or Eloqua or Marketo or Microsoft Dynamics or Oracle or Apache Hadoop. My preference is to use a familiar, standardized, and unified access method. I also want easy ways of configuring connections to new data sources as I need to, still through that same unified access method. So this would be sort of like my aspirin for the headaches caused by the explosion of data API variety. Now here's an example. Explore Analytics is a company that provides data analysis and visualization tools, so they have the need to access a variety of data sources all at the same time. And they can leverage our cloud-based connectivity service when establishing data sources, providing their clients with that same easy-to-configure approach to data access. So in this instance, a cloud-based solution enabled them to provide connectivity without having to worry about upgrades, change control, or managing servers because of changing the APIs. So neither the users nor Explore Analytics needs to upgrade the drivers or keep up with the API changes within SaaS applications. That all gets handled by the cloud service itself. Also, as new data sources pop up, adding support for them becomes much, much easier for them. The second headache here is data access and enterprise mobility. Whether you're migrating enterprise applications to the mobile world or creating new mobilized apps, accessing remote data can really be a pain. In general, enterprise data stores like Oracle or DB2 aren't really ready for being accessed by mobile devices. So when building enterprise mobile applications, which inevitably will have to collect data from sources that aren't geared towards mobile APIs, there's going to be a problem. In many cases, SQL is just not an option from a mobile application, and it is too difficult to code ODBC or JDBC into the app itself. And then we also have the problem of having to access a wide range of data sources, all with different non-standard APIs, just like in the previous headache. So what can we do about it from mobile devices? Now, what many data integration vendors are starting to do, as we cater more to mobile apps on mobile devices, is offer a more standardized set of APIs supported through OData's Open Data Platform. And what this allows is mobile and web applications to query data sources much more easily than force-fitting SQL. And what is shown here on the slide is OData being leveraged from the mobile or web application instead of SQL, going into a cloud-based connectivity service. And that connectivity service understands the language to access data across the variety of different data sources, whether it's out in the cloud or on-premise behind a firewall. And this makes it much easier for the end-user application to code the data access and still get to the data sources that it needs to get to. Motwin is another company that offers a real-time mobile middleware platform for high-performance applications with capabilities for context-aware apps and out-of-the-box connectors for back-end integration. So they deal with these API headaches all the time for mobile apps. Motwin needed to enable better integration with multiple back-end data stores. So what they did was simplify API management in their platform by enabling a single pipe from the mobile apps to a cloud-based connectivity service. Now, for businesses with multiple back-end servers and multiple mobile applications that are accessed by a range of mobile devices and operating systems, this mobile middleware approach provides a more efficient development environment, and this really worked for them. The third headache deals with access to enterprise data, typically residing behind a firewall. And this turns out to be a big problem for SaaS-based or cloud applications. Enterprise data, typically held in relational databases on-premise behind a firewall, pose some security challenges which add to the latency in accessing the data. So normally, if I wanted to get to the data from a cloud app or from a different network even, I would need to open up a new data port and essentially reconfigure the firewall, as well as establish a separate or a new set of authorizations and credentials for every single database that I want to get to. And most likely, you'll require extensive SQL API knowledge for each relational database that you want to access. So it becomes complex and difficult. And like I said on the prior slide, information stored within a database is most likely sitting securely behind a corporate firewall. So getting access typically means a VPN connection or some other option that involves IT and takes valuable time away to help establish. There is an option available that allows you to securely access local data sources from anywhere, and it's part of Data Direct Cloud, and what we call it is the on-premise connector. And this gets installed on the local network machine where the database resides as well, and its job is to direct data requests like a phone operator directing calls. When the call is received, the on-premise connector answers and verifies who is requesting access, then opens a secure line of communications to the database. And this allows Data Direct Cloud to communicate over the assigned connection using HTTPS and SSL because it originates from within the corporate network using that on-premise connector. So using that data source definition supplied by the cloud-based service, the on-premise connector can now direct the connection to the destination database or application data. Much easier than having to go in and reconfigure every time you want to access a different database. MicroStrategy is a company that offers business intelligence software that integrates a full range of reporting, analysis, and information delivery capabilities into a single platform. And their challenge has been to offer their customers the easiest installation and configuration process possible, including both cloud and enterprise data sources. So implementing a solution that minimizes network changes really appealed to them, and it's really required, and it's optimal for them and great for their clients as well. So their customers can now configure and deploy the MicroStrategy BI platform and its data connectivity much faster, and this all results in some smoother proof of concepts and evaluations. So it's been a big win for them. The fourth headache, when you start dealing with massive volumes of data, it's like trying to find a needle in a haystack of needles, and when searching for the right data that provides the smartest insights into the business, it could be pretty challenging. And this all goes back to big data, dealing with large volumes of data. So enter the notion of dark data. That's what I call it. From a business perspective, dark data is really all of that data that is not being looked at by the business in order to make decisions. In general, dark data does not matter to the business. I would estimate that 80% of big data is dark data. Is kind of an alarming statistic. So why should we care about this? Well, just like how dark matter in the cosmos can hide the important stellar metrics that we might want to gather in scientific research, dark data can essentially hide or cloud the information that we might need within big data business analytics and intelligence. So dark data makes it harder to find the right data. We also need a more scalable solution. Besides the dark data challenge, we need a more scalable solution to handle the volumes of data bytes out there in Hadoop clusters and remote data stores. Also, gathering data in bulk and in a way that is scalable and efficient is really necessary for faster analysis of these huge volumes of data. So how do I simplify access to all of this data? Well, big data, in my mind, is defined by an organization's ability to analyze volumes of data, harvest business intelligence from it, and derive actionable insights and make business decisions with it. Dark data is neglected, a lot of times accumulating in archives, Hadoop clusters, remote data stores, grids, log files, and no one really knows what to do with it all. In a way, it's like antimatter that clouds our vision. But if 80% of big data is dark data, not tapping into it, in my mind, also means the results of your analytics and intelligence becomes faulty and suspect and maybe incomplete, and ultimately not useful, and maybe even harmful. So what can we do about it? Well, we can choose to ignore it. That's easy enough. But in these modern times and the reemergence of newer and faster ways of accessing data of all types, there's really a better option that could have a real impact on the business. Establishing data connectivity, either through a cloud-based service or directly from any platform or mobile device to data stores residing anywhere, is really the key that unlocks the dark data mysteries. By using SQL or OData APIs to access the data, we can essentially hide the complexities of proprietary interfaces or unique web services and get to a variety of data sources, no matter where they might reside, and at lightning speed. And if you look at another example here with big data, by applying those same in-database techniques used with traditional data sources and massively parallel processing data warehouses to Hadoop clusters, KXEN introduced new levels of predictive insight. And they did that by analyzing vast quantities of data from their customer-facing channels and across the business. KXEN was recently acquired by SAP. What they do is they use Hadoop and social data pretty heavily in their predictive analytics tools. So faster data connectivity is really important to their approach. And they were able to realize much faster data access involving large volumes of data by accessing things like Apache Hadoop Hive directly using SQL. Okay, let's move on to number 5, data access and transactions. And what I mean is, in highly transactional environments, high performance and efficiency while preserving data security are all key. When you look at high transaction environments, such as stock trading or financial services, they all require super fast response times, and in turn, super fast access to data. So there needs to be high scalability with possibly application failover in case a connection gets jammed or breaks. Data access needs to happen in near real time or close to it. And the data access needs to efficiently use the resources necessary. And this all leads to high throughput operations that are necessary for many critical business processes and applications. So, how can I provide fast data access in highly transactional environments? Well, the best way to guarantee high-speed data access is by connecting directly to the data via SQL, the protocol of choice when dealing with ACID transactions. ACID stands for atomicity, consistency, isolation, and durability. It's really a set of properties that guarantee that database transactions are processed reliably. Atomicity requires that each transaction is, quote, all or nothing. If one part of the transaction fails, the entire transaction fails, and the database state is left unchanged. Consistency ensures that any transaction will bring the database from one valid state to another. Any data written to the database must be valid according to a defined set of rules. Isolation ensures that the concurrent execution of transactions results in a system state that would be obtained if transactions were executed serially. And then finally, durability means that once a transaction has been committed, it will remain that way, even in the event of power losses or crashes or errors. So a smart data driver promotes ACID transactions and is designed for speed, reliability, and application failover. Here's another example for transactional environments. In the Lloyds Bank case, Lloyds leveraged a solution provider, FIS, or Fidelity Information Services, to help automate and streamline their loan processing. FIS created an ACBS, which is Advanced Commercial Banking System. They implemented it, and during their implementation of it, Fidelity addressed this challenge of excessive data access round trips due to poorly constructed SQL calls that Lloyds had been using in the past. So Fidelity's solution was to automate and streamline loan processing using high-performance data connectivity. And as a result, Lloyds realized a 22% performance gain between their banking system application server and the databases, which was a huge benefit for them. Moving on to headache number 6, data access and applications. And what I mean here is number 6 deals with accessing data held in your own business applications. So how do I make my application data more accessible? And the big question here is, how do I do that and make it accessible to users and other parts of the business? There could be a skills gap there. The application developers might not have all the right skills to readily build and optimize the data connectivity that's needed. And in order to custom build the driver, it looks on the surface and under the surface to be too complex. And even if I could build the driver, how can I provide a universally accepted data access method so that everyone can easily get to my application data? What's needed here is an SDK that enables a quick and easy implementation with customized access to your application's data. The SDK would expose the application's data through standard APIs like ODBC or JDBC and enable SQL access. SQL execution is optimized by leveraging the data source query execution engine that comes along with the SDK. Basically here, when we can customize access to application data by SQLizing in a way or transforming a proprietary API into a standard one with very little additional code that must be written. Coins is a construction company based in Europe, and basically Coins had built an application with a business logic layer that accessed their database for information on accounts, cost estimates, contracts, and more. And their business logic layer handled security and data access and validation, but it was all internal. And what they wanted to do was allow third-party reporting tools to access that same data. They were able to quickly and easily custom build an application adapter that allowed connectivity to the business logic layer of the native Coins reporting solution. And in the end, opening up the access method with a standardized ODBC protocol led to massive productivity gains for themselves. And finally, number 7 on my list of 7 involves keeping track of the most current and up-to-date data in my regular reports on how the business is doing. This leads to a lot of times manual and tedious report generation, and the prospect of accessing and correlating all the data coming at you from disparate systems can be exhausting. These symptoms plague the thousands of marketing operation professionals out there who are fighting a losing battle with organizational data, and they really are on the verge of a data meltdown. Data overload is a common complaint in marketing operations, and failing to reconcile different data sources can lead to mismatches of fact and misinterpretation of what the data actually means. Poor data quality is another problem. If you can't make sense of the information you are collecting, you're likely not getting the data accuracy you need to present the right metrics. Also, it's common to find it difficult to segment on data in ways that are needed. You just simply haven't got enough sources or context to make sense of the data in front of you. And finally, with poor feedback cycles, you're constantly running around having to update data or create ad hoc lists, views, and reports to share out with various stakeholders. This is the fastest route, in my mind, to a serious data meltdown. And with inflexible reporting, you might believe that your reports are already perfect, but you find yourself frequently getting into arguments with users who are fed up with you churning out the same format month after month. If people are asking for too many reports and you can't keep pace, then your reporting tool could be to blame. And this all leads to manual, tedious, out-of-sync report generation. So how can I automate report generation involving multiple data sources? Data integration and collaboration can be streamlined with 5 key stages of a typical data process. The first is connect. Instead of manually exporting data from your SaaS or on-premise application, this can be automated using an application like Progress Easel. The second is combine. Using templates for common business reports, you can gather data from your favorite SaaS or on-premise applications and combine that data based on common patterns and rules. The third stage is store. Instead of installing and managing your own data warehouse, Easel can provision a cloud data mart on demand to centrally store and automatically refresh the combined data from your applications. The fourth stage is sharing. Email makes it difficult to effectively collaborate because conversation threads fragment, and that leads to many copies of the data that someone must manually reconcile. It doesn't work well with large attachments. Dropbox governance can be an IT nightmare. What Easel does is it syncs your reports just like Dropbox does, but with corporate oversight of users. And the fifth and final stage is consume. Easel is compatible with all of your favorite BI and reporting tools. It produces reports natively as Microsoft Excel files. It can also provide standard ODBC and JDBC interfaces for connecting tools like Tableau, ClickView, MicroStrategy, SAS, Cognos, and anything else. Here's a good example. Good Done Great. It's a US-based role-based application partner with a hosted private cloud solution. And what they do is they provide strategy, technology, and managed services for corporations and foundations so that the employees of those companies can make a more meaningful and effective impact through charitable giving. And their challenge was dealing with reporting limitations and getting all the right data from various sources in a cohesive and synchronized manner. They were able to use Easel, and they built automated custom reports that are easily synchronized, and as a result, they were able to provide access to information views and reports to their customers. And they could also generate reports on aggregated views for internal metrics. So let me summarize this way. So I talked about the 7 top data API headaches, and here I have some Aspirin-oriented, if you will, recommendations for how to alleviate those headaches. Cloud-based data connectivity services help ease the data variety chaos. The OData, Open Data Platform, enables standardized data access for enterprise mobile applications. We have some new technology that provides low-touch access to enterprise data through a firewall. SQL access to Apache Hive or Apache HBase in big data environments helps ease the headache of dealing with volumes of data and dark data. Direct access to databases using data drivers, architected for speed and efficiency, is paramount to preserving ACID transactions. Customized access to private application data can be built quickly and easily. And finally, automated and synchronized reporting helps ease the headaches involved with integrating all the right data on a regular basis. So with the technologies available today within Progress Data Direct, we can simply and easily connect to data residing on-premise, behind a firewall, or in the cloud from mobile, enterprise, cloud applications. Thank you very much for listening. I hope this was all useful to you, and please feel free to contact me, Jeff Reeser, with any questions or comments you might have. And now let me hand it back to Vance for any additional questions.
Jeff, excellent session. Touched a lot of API headache hot points, I'm sure, among our audience. Looking at some comments here, we've got questions both at the high-level architecture as well as implementation. So with your permission, let's go right to questions.
Sure.
You know, Jeff, the one thing that comes through loud and clear in your presentation is this concept, which we believe here, too, at Integration Developer News, that integration is driving a lot of the hot market opportunities here, whether they be in big data or SaaS or mobile. When you back up, you really see that integration is a real key enabler here. And so to set the stage, this first question kind of goes into this view that Progress has. Can you make the distinction between what people might think of as traditional enterprise data integration, either with ETL or ESBs or SOA, and this new concept you talk about, the data API?
Sure, and I think the biggest distinction is really starting to deal with more and more different and varied data sources than you ever had to deal with before. I mean, in the past, you're going to a single database, getting the information and processing it. Nowadays, and it doesn't matter what industry you're in or what kind of application you're trying to build, there's always going to be a need to drive through that application with data, and you most likely need to get to multiple data sources, and that's really goes back to my very first data API headache that I talked about. How do we deal with that wide variety of different and up-and-coming new data sources out there, whether it's in the cloud or on-premise? Traditional approaches don't work anymore when you're talking about data integration and having to deal with all of those APIs.
You know, that's well said. In fact, a theme came in, you mentioned a couple of times, the idea of being able to leverage SQL as a unified access method, and a question comes in that asks about that. Is the speaker suggesting that I can use SQL to get to multiple structured and unstructured data sets, including Hadoop?
Well, using SQL does provide us with a good, standardized, open, and fast way of getting to the data. When you talk about Hadoop, though, Hadoop has a lot of unstructured data inside it. And Hadoop itself, it's not a database. It's a distributed file system. And what you need to do is get that right data into a data source like Apache Hive or like HBase in order to access it correctly. So there's always going to be some kind of structure to the data that you're getting to. It might be coming from Hadoop originally, but you have to have that middle data source that you can use SQL against or use your data API against. We're primarily dealing with the connectivity to that data. So we have a cloud-based service and we have a direct connectivity that primarily supports either ODBC or JDBC and now OData as well from mobile devices. And that's all the application on the user end has to know about. The translation and understanding what the sometimes proprietary and native APIs are within the data source out in the cloud, for example, that's all handled within the cloud service itself. So all you would have to know and understand is the schema of the data and what kind of a SQL statement you need to create within your applications to access the data. All the rest of it, the translation, the maintenance of the native APIs for the data source, that's all covered by the connectivity service.
Oh, excellent, excellent. Mobile certainly is a hot topic for many people. There's a question here that comes in about that. Mobile integration is one of our major headaches here. Does Progress offer a mobile middleware platform?
Progress offers a mobile development platform through Rolebase. What we do with Data Direct is provide that connectivity that most likely would be needed within that mobile application. As you're building out a mobile application, you inevitably will have to go out and get some data from a data source, and that data source might already exist, might be behind a firewall. So with our new OData support, you can do that. You don't have to worry about ODBC, JDBC, which a typical mobile application developer might not readily understand, but they might easily understand OData and some of the RESTful APIs that are supported in that sense. So we do provide that support.
Oh, very good. And just to drill down on that, so people that might have good enough SQL might not notice that until it goes into a multi-point integration or even an off-premise integration scenario. Are there ways that you're finding your customers are looking at how they've worked with SQL that might have not gotten a lot of attention in years that can help them maybe fine-tune it a bit more for these multi-point integrations and projects?
Sure, and using the right data drivers can make all the difference in the world when something like performance is so key and integral to certain applications within industries like banking and finance, for example. It's absolutely key to make sure that that data access happens as quickly as possible.
I see we're just about out of time, but I think we have time for one last question. So simply the question says, Jeff, can you give us a sense of the way that folks can either take a trial with your offerings via the cloud or do some other way to evaluate what you have?
Sure. We have trials available for Data Direct Cloud, which is all web-based, and you can get to that through our Progress website. And we have trials just to download the data drivers that you can build into your applications. We have case studies out there for all of the products that talk about, in more detail than what I was able to talk about today, how the customers used our drivers, used Data Direct Cloud, and we're successful in building the right application adaptation. We focus on the data-driven application development environments that we have. That's our big application PaaS environment that we talk about as Pacific. And within that, we have runtime capabilities like our data direct drivers that we can merge in. And we also have other pieces like a business rules engine called Corticon. For the sales and marketing types that are out there building these reports every week, something like Easel is invaluable to them to keep up with a synchronized set of clean reports that they can use maybe on a weekly basis.
Really great session. Jeff Riesler, Senior Product Strategist at Progress Software. Thanks very much for taking us through not just the headaches of data APIs, but a little analgesic, which is certainly in high demand out there. Thanks again for a great session.
Thank you very much.
And as we like to do here at CloudCon Integration, we're going to leave a slide up here. Jeff mentioned many valuable resources, not only the cloud-based downloads and trials, but some other white papers we didn't have room for here in the room. They are available through these links at this slide. Thanks again, Jeff, and thanks again, everyone.